I've been challenged by Cameron Tillman to do this lecture in 8 minutes or less. So you can, if I go too quick and to talk too fast for you, you can blame Cameron on this one.
You can also watch it again, online students.
Yeah, as he says, you can watch it again and 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 again. Alrighty.
How come Cora gets to sit in on classes?
Yeah,
Who?
kick her out on Wednesday.
She's a student, kid. She is not an adult student. Well, if it, oh, you want to call it discrimination, then I'll have to separate the two of y'all. Well, he's an adult. He knows better. All right. She's trying to get me off my subject here. Guess it would help if I turned it on. All right, we're going to talk about classful and classless IP addresses. We're going to review VLSM, variable length subnet mask, and we're also going to talk about classless interdomain routing, or CIDR. You know, your slash number, that's the CIDR. Okay, VLSM means that you can have multiple subnets. We've been doing that for 2 weeks. Don't ask me why they put this in chapter 6. This should have been in the network book in the first 11 chapters, right? Or at least the first chapter in this book. Don't ask me why they put this halfway through the distance vector protocols. So I'm skipping around a little bit. Back in 1981, they found out, oh my goodness, we are going to run out of IP addresses on 32 bits. All right. So what they do, they called the IETF, and the IETF said, hey, let's come up with this cool thing called CIDR. Everyone's like, huh? CIDR? Class-specific interdomain routing. That means you can use multiple subnets. You can only cut down the portion of what you need. How many hosts do you really need? So classful IP addressing. As of 2007, there are over 433 million hosts, and we were able to save a lot of time, right? In 1994, they said, oh my goodness, we're going to run out again. So we developed NAT, so you can use private IP addresses after private IP addresses after private IP addresses. And then they said, okay, let's just use the private IP addressing, the 10s, the 172.16s, and the 192.168s. Make sense? Now we have unlimited IPv4s. Do we need to go to IPv6? Why? Because everyone else in the world's going to it? We're going to be left behind? Do it? Okay. Remember, IPv4 is a 32-bit address. The numbers to the left are the hosts, or networks. The numbers to the right are your hosts, depending on where you break it off, right? Class A begins with 0, ends in 127.255.255, with the exception of 127.001. 127.000. Anyone know what that is? It's your loopback address. Class B begins with start with a bit of 1 and have a 0. It gives you 128 to 191, 255, 255, 255. Then you have Class C that has basically an 11 and a 0 right here on the very far left end of the spectrum. And it gives you 192 to 223, 255, 55, 55, right? Notice something here. If I start with 0, I turn on 1 bit. Remember in our octet, if we turned on 1 bit, no matter whether it's the host or the network, what's your value of your subnet mask? 128. If I turn on 2, what do I have? 128 and 64? Guess what if I turn on a 3rd bit? That'd be your class D. Turn on 4 bits, your class E. That's where they came up with them. Simple way to remember them, right? Okay, an IP address has 2 parts. It has the networks and it has the host. Networks are on the left side. Well, let me do it this way. The networks on the left side, hosts are on the right side, right? Depending on where you break it apart, depends on where your host and your network are. Here's an example of the class full. You'd have a network, host, host, host. Class B is network, network, host, host. Class C is network, 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 host. All right? Notice we have our /8, 16, and 24s in our blanket mask. Class A, you can have 16,777,000 plus addresses. Class B address 65,534. Why is it not 65,536? Because host is 2 to the n minus 2. All right? Why am I only seeing 254 hosts, not 256, right? If I have a full octet, it's 256, right? Same thing, 2 to the nth, which is 2 to the 8th, minus 2 is 254. So if you want to go show a kid in high school how smart you are, go, what's 2 to the 8th minus 2? They'll look at you and go, 254. Be like, huh? Never mind. You just look weird doing it. Come on, I'm just trying to give y'all some laughs tonight. I've only basically been up since 3 o'clock this morning, so I'm already dead tired. So this class and next class is just going to get even better. Purpose of a subnet mask, what is it? It tells you where you break your host and your network addresses from each other, right? Classful routing updates. Okay. Recall the classful routing protocols, which we haven't got to yet, but I'm going to when we get to the distance vector here. A classful routing protocol is RIP version 1, where you have to use the entire class, either A, B, or C, to define your scope of your hosts. RIP version 1 does not send a subnet mask, that's why it's classful. So you send 172.16.1.0, right? 172.16.0.0. And that's all it does, just send these two. That's it. It's a class full. What is the advantages? CIDR gives you more efficient use of the IPv4, right? It also requires the subnet mask to be routed in the routing update so the address, otherwise the class is meaningless. So that's where we come into the variability and subnet mask. Y'all remember where you had the 4 LANs out here starting number 2? You had like 24, 25, 26, and 27. And you were trying to figure out how to get them all subbed into the same static route. That's what VLSM is. That's why I wanted to teach this before we got into static routing. I don't know why I didn't. And that helps you with your route summarization. What is route summarization? Just means here's the list of all the routes that my router goes to. Classful. Do you include the subnet mask? No. VLSM? No. Ability to send supernets? No. If I'm going to do classless, you bet your sweet bippy I better be able to do it. Here you go. Here's an example of what your final exam will look like. You like that? Just for that, I'm going to add another section for you. All right, VLSM and classless routing. If I'm using this, each one of these are subnetted. That's the 3s, that's the 4s, that's the 1s, that's the 0s. And to transfer all throughout this router, this bad boy is going to have a huge routing table. Anyway, VLSM basically is the process of subnetting a subnet. Basically, you start out with the highest level of subnet that you have, and then you break it down by the amount of hosts that you need. Okay, so if I have 5,000 hosts, that's going to be my top level. 2,500 would be my next. Keep on coming down. You always find your biggest amount of hosts and shrink it down. What happens when we call auto-summarized or auto-summarized routes? Wouldn't that have been handy when you did your default static routes? Auto-summarize my routes so that it would automatically go to your highest one for that network, right? Wait till I show you how to do RIPs. You're just going to fall in love with the routing information protocols, RIPs, RIP version 2. Instead of having to guess it, it does it for you. All right. Steps to calculate a route. Counts the number to the left of the most matching bits to determine the summary route's mask. Then it copies the bits and adds zeros to the rest of it to give you an idea of what it's going to be. Any questions? I slide. It was 9 minutes.
Yeah, a little bit over. That was still good.
And y'all are all laughing.
I'm impressed.
VLSM is not much to it. That's when I said I knew I could do it. Because y'all have been doing this for a while, so y'all understood what I was talking about, right? Raise your hands if you didn't. Oh, raise your hands. Okay, y'all understood what we were coming from and the difference between the host and networks, because that's what we've been doing for like the last 4 weeks, right? Y'all are not as lively now. I think I'm gonna have to start putting firecrackers underneath your sheet or something.
No, don't do that.
Either that or put electric pads right underneath your seat so It goes. Just hit the button. Like, okay, seat 3, row 2, or row 2, seat 2. Cameron jump out of his seat. See, Cameron, it's not just this class or net admin. Alrighty. Distance vector routing protocols. Now I'll go a little bit slower on this so you can kind of understand it. We're going to talk about distance vector routing protocols. We're going to talk about RIP, Routing Information Protocol. Now there's also RIP version 2, which we'll talk about on Wednesday. I'm going to cover RIP version 1 and RIP version 2. Then I'm going to cover EIGRP, which basically has the exact same thing as IGRP, and I don't have the slides for IGRP. So we're just going to cover EIGRP next Monday. And then you'll have labs next Wednesday. Everyone cool with that? Just making sure that everyone, and then what we'll do is we'll cover the, instead of the distance vector, we'll do it cost, and then we'll do OSPF all on the same day. So you can understand the cost and how OSPF measures its metrics to route information. And then we'll start focusing on getting all the packet tracers done and getting you ready for your hands-on vinyl. Okay. Distance vector protocols are RIP, RIP2, IGRP, and EIGRP. What is the meaning of a distance vector? Two things, distance and vector. Right? Cisco has such great naming schemes. Distance, how far is it for me to reach Anthony? Vector, which way should my traffic be vectored towards Anthony? Should it go to Jared to Anthony? Should it go to Todd to Anthony? Or should it go to Brent to Anthony? It's going to go to Todd because that's the quickest way, right? That's how distance vectors work. Okay, they have periodic updates, which you can set the timing on that. You have neighbors, which will be like CDP neighbors. Broadcast updates, where it sends updates and just shoots that routing table all the way around. Okay? That's really all distance vector does. Routing protocol algorithm is defined as a procedure for accomplishing a certain task. That just sounds weird, doesn't it? What task is it going to accomplish, Cody?
I think it's routing, but honestly, I've zoned out for a second. So.
Okay, let me just explain this to you. We have a fast Ethernet coming out of router 1, then serial 00s between those two routers, and then you have fast Ethernet probably over here, even though they didn't label it. If I'm going to send something out of this fast Ethernet to get over here to this router, what am I going to see? Well, my network address is going to say, I'm going to have, why does it say hope instead of hop? It's one hop, or there's really no hops because you're already at your router. If it wants to get out to the 2 network, it'll actually have no hops because it's still in this router going out, right? This router sees this. I don't have a hop to go to either side. Now, if I need to get back to the 1 network, which is over here, I've got to go through 1 router to get to it. Does that make sense? When we're always talking about that next hop router. Criteria used to compare the routing protocols in terms of scalability, resource usage, time to converge, and implementation and maintenance. What does all that really mean to you? Path the least resistance, right? How am I going to get there the quickest and easiest? Here are the advantages and disadvantages of distance vector. The advantages are that it's simple implementation and maintenance. Very simple. Low resource requirements. It doesn't take much to just forward the packet. Disadvantages. It's slow convergence. It means the updates take forever. Okay? Limited scalability. You really can't have a big network. And routing loops can occur if you have inconsistent routing tables between the routers. And that's always fun. Imagine trying to chase down a bunny when you're drunk. Unless you fall on it, you're probably not going to catch it, right? That's how hard it is to find a loop with inconsistent routing tables. All right. Initial network discovery. Basically, as they pop up, they go, okay, here's my routing table. I'll send it on so everyone knows how to find each other. If a routing protocol is configured, they exchange information. If it's not, they don't. Why not? Because there's nothing to change. All right. If there's new information, we can replace our T1 with the T3. The cost is going to be a lot smaller, right? So we'll get faster bandwidth. So they'll resend out the information. If no new information is reached, the convergence is reached. In other words, so long as there's no new information, you have convergence. Everyone's on the same page, everyone's on the same table. Before a network is completely operable, convergence must be reached. Then you can have some idiot, like Cole, go plug in a WAP, or another router, or another switch. No, you're not an idiot, Cole. I just like picking at you. Someone is going to go screw something up, and then you got to go find it, right, Todd? And it's usually a one-striper. Then he gets called up all the way up through GS-13s and Chief Master Sergeants and majors or lieutenant colonels. He gets his butt ringed. You know, because you don't want to screw this up after you get it set, right? How many hours do you think it would be to set all these routers and switches up?
Years.
Well, you can have about an hour and 15 minutes to do that. You thought you were going to pass my class, Cameron?
That's the final.
Start preparing. Let's see, just here we've got 1, 2, 3, 4, 5, 6, 7 routers. And it's 4, 8, 12, 16 subnets on each one of those. So 8, 8, 8, and 8. That's 32 routers, and then you start coming 32 routers with 56 subnets. You saw how quick I did it. Christian and Aaron are back there like, oh, I don't think so. And Cole will have a heart attack.
I'm dead. I'm almost dead just looking at it.
Rip and Rip version 2. The difference, you're going to have your periodic updates. We call those time intervals. How long is it going to be before we switch the routing table around? RIP uses 4 timers. An update timer, invalid timer, hold down timer, and flush timer. And now I'm not talking about a toilet. Update timer. How often will this data be updated? If there's any updates, it triggers an update. And then it starts counting down for a new update timer. An invalid timer means if I run into an invalid configuration, it sends out an invalid message, and then it starts that timer. Hold down timer. Remember we talked about CSMA CDs and CAs, collision detection, collision avoidance. That'll hold down the router sending anything until such a time as it's ready to send. And then flush timer, it flushes out the routing table. Bounded updates or EIGRPs, where they send partial information. It's not periodic, it just sends it when it wants to. Only when a new topology is entered. So this would be Cole's idea of fun. He would hope that everything's EIGRP so you would never notice. Triggered updates. Conditions in which triggered updates are sent. Interface changes their states up or down. Yes, Aaron?
Can you go back a slide? They put it wrong on the second part, on the second dot EIRPG.
I think they were thinking military terms, RPGs. All right. Conditions in which triggered updates are sent When an interface changes states up or down, administratively up or down, a route becomes unreachable. In other words, Cody's not going to answer his phone when I call. A route is placed back into the routing table. Okay. Here's what we get if we don't have synchronized updates on EIGRP. We got what we call random jitter. You all talking at once, what's going to happen? No one can understand anything that's going on, right? One person talks, everyone listens. Everyone gets the information. You want to synchronize your updates. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3. You catch it? Not that I was really trying to count how many people are in here. But it is nice to know that 13 students showed up. Routing loops. What is a routing loop?
I'm guessing a headache.
So when I get stuck in an infinite loop, just sits there. I don't know where I'm going to go, but I'm going to run out of times to live. This one says to go to this router says go to this router, this router says go to this router, this router says goes back to where you originally got sent from. And no one knows where that end network is. That's a router loop. Static routes, route redistribution, slow convergence, incorrectly discarded routes. That's always fun. If you have a routing loop, it's just going to cause you a headache and it's going to slow your network down. Because you just keep getting things thrown in there to that same network that doesn't exist. What's going to happen? It's just going to keep going. Here's the best definition. It's a routing loop whereby packets bounce infinitely around the network. So if 10.4.0 goes around, guess what? It's just going to keep bouncing amongst these guys. It's like talking on the phone to the most annoying person in the world. You just want to set the phone down and go to the next room, cook your dinner, sit down, watch TV, come back 30 minutes later, and they're still talking. Okay? Same idea. All right. That's the 5th yawn I've seen. Don't yawn anymore. This is where we... How do you end those, though? You set up maximum hop count. Set it to 30, so after 30 it's gone. They discard it. After 16, it's gone, it's discarded. Whatever you want. Once it marks it, once a router says it's infinitely gone, it'll never take any more packets to that network. You can do hold down timers where it won't accept any changes for the specified period of time to make sure the changes are correct. Oh, why do we have to cover this? The split horizon rule. It's used to prevent routing loops. A router should not advertise a network through the interface from which the update came. Because then you're just causing another... once it came through there, you can automatically assume that they know about it. So just only forward it to the interfaces that have not gotten it. Or that it didn't come in. So if it comes in on serial 000 and I only have 4 serials, I'm going to send it to the other 3 serial ports. Because I don't need to send it back the way it came. That's what we call split horizon. Then you get the fun one, the split horizon with the poison. Where it intentionally falsifies routing information. The time to live field. Remember, we talked about that. How many hops are we going to let it go? How long are we going to let this go before this packet expires, right? It prevents those loops. So, here's a distance vector protocols. Remember, you only have RIPs and you have GRPs, right? Speed of convergence. Slow. It's fast on EIGRP, right? We talked about convergence on EIGRP is really cool. So that's Cameron's favorite. Scalability of the network. They're all small if you're going to use RIP or IGRP. If you have a large network, you want EIGRP. So define a small versus large network. You'll need to know that. The use of VLSM. Version 2s, the enhanced, which would be version 2 of EIGRP. you can do it. Prior to, you could not. Resource usage, remember, it's for large networks, it's going to have medium. Implementation of EIGRP is complex. There's a lot of thought to it. The features of RIP. Split horizon reverse with poison. It can load balance. It's easy to configure. It's simple. Router RIP. Tell me the network and I'm done. Y'all are going to love these. Trust me. Features of EIGRP. Basically the same thing. Does route summarization because it can use VLSM. None of the other ones could, remember. RIP version 2 could. But if you're going to be subnetting with VLSM, use EIGRP. Unless it's a small network, then use RIP version 2. Is there any questions, items, concerns, gripes, moans, complaints? What do you think about that one, Cameron?
I like it.
That was 20 minutes. Well, no, I'm sorry, that was 16 minutes.
It's okay. You said you take this one a little slower.
I did. Almost double the time. Did I kind of explain how distance vectors work?
Yeah.
Now, what we're going to do on Wednesday, I'm going to go through RIP 1, RIP 2, GRP. So we'll have 3 chapters on Wednesday to cover up everything so you know what's going on with distance vectors. That's why I want to talk about distance vectors. Then I want to show you how each one works. And when you see the commands on these, you're going to flip out. You're going to be like, why didn't you teach us this earlier? Have you ever had an instructor teach you the easy stuff first and then go to the hard stuff?
No.
Yes. Best instructor ever. He's in the military though. He's like, okay, this is what I'm supposed to show you. Now forget that. This is how you do it.
No questions?